So we have seen how to find prime factorization using factor trees. So this is a tree, and it's a factor tree because you have used it to find the prime factorization of any given number, that is the number 36 in this case. And we said that in the second video, that is this one, we want to discuss the second way, another way to find the prime factorization. And this particular way that we are going to discuss here is important because as your number gets bigger, greater and greater, okay, if the number is larger, having more number of digits, then in that case, using this way, that is using the factor tree and finding the prime factorization, I mean, that will be really very tough. Suppose you have number, suppose it is 1080. Now, I mean, if you go on factorizing in this form first, because only then you can use a factor tree, you have to first factorize it in the form of, you know, whatever the factors it has. So to find all those factors, that's a really very tough job. So there's a simple way, to find the prime factorization of larger number. So the way that we are going to discuss is will be, I mean, just first apply that on 36 itself. So if you apply that method on 36, so say we have 36, what you have to do is just go on dividing it, okay, go on factorizing it by using the prime numbers and start it with 2. Is this number divisible by 36? Yes, this is divisible by 36 because it has 6 at its units place, and this will be 18. Okay. Now, is this number divisible by 18? Yes. Sorry, by 2. Yes, because it has 8 at its units place, so 9. Now, since it is 9, it cannot be divided by 2. By 3? Yes, by 3 it can be, and this is 3. Right? So, what will be the prime factorization of 36 by this method of factorization? It will again be, you have 2 2's, so 2 times 2 times, you have 2 3's, so 3 times 3. Okay, so this is the way, and you can see that the result is same to this one. So what does that mean? Whether you apply this factor tree method or this method of dividing and factorizing in the form of prime factorization, in both the cases you'll get the same result. Now let's take a larger number. And suppose you take 1080. You have 1080. Now, using the factor tree method, that's a tough job. What can be the easier way? The same that we have discussed just now. So start by using the smallest prime number. And so is this number divisible by 2? Yes, because it has 0 at its units place. So 2, this will be 540. Is this number divisible by 2? Yes, because it has 0 at its units place. So 270. What about this one? Is this number divisible by 2? Yes, because it has 0 at its units place. So this is 2, 1, 3, and 5. I mean, you can just divide it and check it. I mean, just if you're not able to, if you want to go with the traditional method of dividing and finding what will be the next result, you can do it. I'm just trying to show you that how you have to calculate it. Now what about 135? No, this cannot be divisible by 2 because it has 5 at its units place. What about 3? So to check the divisibility by 3, you know that if you add all those digits, and if after adding digits the number is the sum of those digits is divisible by 3, then that number is divisible by 3. So 5 plus 3 plus 1 is 9, right? If you add 1 plus 3 plus 5, this will be 9. Since 9 is divisible by 3, therefore this number is divisible by 3. So 3 45. What about this one? Yes, again, if you add 5 and 4, this will give you 9, and 9 is divisible by 3, so 15. What about 15? Yes, 5 plus 1 is 6, 6 is divisible by 3, so this is 3 and 5. Now it can only be divided by 5, right? So in this case of 1080, what will be the prime factorization? You have 3 2's, so 2 times 2 times 2. You have 3 3's, this will be times 3 times 3 times 3, and you have 1 5, this will be 5, and this is the prime factorization of 1080. So 2 ways. If you have a smaller number, then you can apply the factor tree method, but if you have larger number, then that method will be a tough one, and this method of dividing and finding the prime factorization is the easier one and the quicker one.